Hello, future engineers. Welcome. I'm so glad you're here today because we are diving into an absolute masterclass in coordinate geometry. Now, I've been teaching for over 30 years, helping students just like you absolutely crush the JEE Main and WBJEE for EduNova Bangla. And I'll tell you my secret right now. We're going to conquer this topic not by endlessly memorizing formulas. No way. We're doing it through pure graphical visualization. Think of this explainer as your ultimate one-shot revision. Literally, if you can see the math, you can solve the math. Let's get right into it. All right, so here's our roadmap for this explainer. 1. Basics, points and distances. 2. Straight lines and slopes. 3. Conics, taking us all the way from circles to hyperbolas. 4. Graph visualization mastery. And finally, number 5, our ultimate JEE and WBJEE strategy. Okay, section 1, let's dive right into the basics, points and distances. Listen, to truly master coordinate geometry, you literally have to mentally step inside the graph. Picture this, you're standing right at the origin, right at 0, 0. That is your home base. Every single move you make from here into the 4 quadrants is governed by one super simple sign convention. If you walk right and up into quadrant 1, boom, everything is positive. Walk left and down into quadrant 3, everything is negative. The x-axis is just the flat ground where y equals 0, and the y-axis is that vertical wall where x is 0. Makes sense, right?
So now that we're on the grid, what's the most basic tool in your arsenal? The distance formula. It just measures the straight path between any 2 points, x1, y1, and x2, y2. But here's the thing. If you look closely, this isn't just some random scary string of algebra. It is literally Pythagoras' theorem wearing a disguise. You are just calculating the hypotenuse of a right-angled triangle drawn right between your 2 points. That's it.
Now pay attention to this, because this is my 30-year memory trick for the section formula. When you need to find a point that divides a line segment in a ratio of m to n, you've got 2 formulas, right? But look at how internal division uses plus signs everywhere, while external division perfectly mirrors it with minus signs. Please, do not memorize 2 completely different equations. Just remember this golden rule. Internal is positive, external is negative. Done. Moving from lines to shapes, the midpoint is literally just taking a simple average of your x and y coordinates. Easy. But the real exam favorite here, the area of a triangle. You take half the absolute value of this big cyclical equation. But here is the visualization trick, guys. What happens if 3 points lie on the exact same straight line? Think about it. They form a squashed, completely flat triangle. So the collinearity condition simply means the area formula equals exactly 0. 0 area, 0 triangle. Moving right along to section 2, straight lines and slopes. Every single straight line has a steepness, right? And we call that slope, or m. Slope is just the angle of inclination, the change in y over the change in x, or just tan theta. Now, parallel lines are visually pointing in the exact same direction, so obviously their slopes are perfectly equal. But here is an absolutely crucial point. If you grasp the perpendicular lines always have slopes that multiply to exactly -1, you are going to save crucial seconds on your exams. Just flip the fraction and reverse the sign. Game changer. All right, here are the 5 forms of straight line equations. Now, a massive mistake I see students make all the time is treating these like 5 totally different concepts. Don't do that. Think of them not as different lines, but just the exact same line wearing different mathematical costumes. Depending on what the exam question hands you, maybe a slope and a y-intercept, or maybe just 2 points, you literally just pick the costume that fits the occasion. Oh, please mark this formula down immediately. Finding the perpendicular distance from a specific point to a general line equation is highly, highly testable. You just plug the point's coordinates straight into the line's equation, take the absolute value so it's guaranteed positive, and divide by the square root of a squared plus b squared. It's a pure plug-and-play formula that you will see repeatedly in the exams. All right, section 3. We're bending those lines into conics, circles to hyperbolas. Think about circle, it is perfectly symmetrical. Whether you use the standard equation or the general expanded equation, your ultimate goal is always exactly the same. Hunt down the center coordinates and find the radius. Once you have the center and the radius, you own that circle. Need the length of a chord? Easy. Just visualize a right triangle dropping from the center straight down to the chord. Take a mental screenshot of this table right now. This brilliantly illustrates how all these equations connect. Look at the ellipse and the hyperbola. Their equations shift by just one tiny sign, a plus for the ellipse, a minus for the hyperbola. Now look at the eccentricity, e. For the ellipse, it's the square root of 1 minus b squared over a squared. For the hyperbola, it's 1 plus. Master this beautiful symmetry, and I promise you, you won't have to blindly memorize a thing.
And here's a crucial detail so many students drop on test day: the hyperbola asymptotes. These are the straight lines, y equals plus or minus b over a times x. Visualize them as invisible boundary lines forming a giant X on your graph. The curves of the hyperbola hug these lines tighter and tighter as they stretch off to infinity, but they never, ever touch them. No touching. Okay, section 4, graph visualization mastery. This is where the magic happens.
Here is a question I ask all my classes. Why do we blindly memorize complex equations when we can just draw them? The best exam strategy dictates that if you are ever stuck on a coordinate geometry problem during the exam, stop calculating immediately. Literally, put down the algebra and start sketching. Draw the axes, plot the points, rough out the curve, let the visual guide your math. These are your 5 foundational shapes. A parabola looks like a bowl. An ellipse is a squashed, stretched circle. A hyperbola is 2 mirrored curves turned away from each other. By visualizing the symmetry and knowing exactly where the major and minor axes lie for each shape, the math practically solves itself. Why? Because you can physically predict what quadrant your answer should end up in before you even calculate it. All right, Section 5, let's talk JEE and WBJEE strategy. If you review previous year question patterns, the high-yield topics displayed right here are pure gold. Exam setters absolutely love testing the angle between lines, the point-to-line distance, and that tricky interplay between eccentricity and the latest rectum in conics. If you master the graphical intuition behind this specific checklist, you are going to be fundamentally unshakable on exam day.
So remember, don't memorize, visualize. When you look at the exam paper, remember that an equation is really just a map. You don't need to fear the test because you now understand the fundamental geometry that builds these spaces from the ground up. You know the terrain. Think about it. If a complex coordinate equation is simply a beautiful picture drawn with math, what else in the universe are you finally ready to visualize? Coordinate geometry isn't just about passing your tests. It is literally the language we use to describe space, motion, and the entire physical world around us. So keep drawing your graphs, keep questioning those formulas, and keep trusting your visualizations. You've totally got this, and I will see you next time on The Explainer.